How you doing? Thank you for tuning in to this here video presentation by Mr. Larry Whittington, or as he want to be known, Mr. Whit. Mr. Whittington's know all about mathematics, and that is why he founded the Fort Bend Tutorings. Today we're going to learn about word problems. Not the kind where you curse people out, but the mathematical kinds. The kind I don't be understanding at all. Alright, get your ink pen and your pencil ready. Take notes, because you finna learn from Mr. Whit.
Hello ladies and gentlemen, this is Mr. Whit with Fort Bend Tutoring, and today's tutorial is geometric word problems, our fifth word problem tutorial that we are bringing to our YouTube channel, Fort Bend Tutoring. Alright, so here we have problem number one, ladies and gentlemen. That's right, problem number one. The length of a rectangle is 3 centimeters less than twice the width. The perimeter is 54 centimeters. Find the width. Anytime you have a geometric word problem, the first thing I suggest you do is actually draw a diagram of the word problem. So whatever shape they're talking about, whether it be a triangle, a circle, a square, draw it out on your paper, because seeing is believing. You want to feed your brain with as much information as possible to solve this problem. So you're giving yourself an opportunity to see the shape that they're defining in the word problem. So let's do just that. So I'm going to start out with a rectangle here. So I have my rectangle. Boom, all right? I'm sure yours looks better than mine, but we're going to work with this one. Here, it says that the length of this rectangle is 3 centimeters less than twice the width, which means that out of the length and the width of the rectangle, my unknown value is the width. I don't know what the width is, so I'll just label that as W. That's just the width. I don't know what it is. However, the length of this has a definition. I've been told that it's 3 centimeters less than twice the width. So anytime you see the phrase less than or subtracted from, the second part goes first. So we'll put twice the width, which is 2W, minus 3 as the length of my rectangle. So here I have it. Then it goes on to say that the perimeter of this rectangle is 54. And remember, the perimeter is the distance around this object. So one thing you should definitely keep in mind, and one thing that they're assuming, is that you know the perimeter of a rectangle's formula. So here it is. The formula for the perimeter of a rectangle is 2 times the length plus 2 times the width. Just like that. And we'll make a note that the perimeter is 54. All right, so let's keep that in mind. So being as though I have my diagram now, I have it labeled, and I have the formula for the perimeter of a rectangle, I'm going to replace all the values that I can in my formula with the given information, so that hopefully I'll end up with one equation with one variable. That's always your goal when you're solving word problems, ladies and gentlemen, to be able to write one equation with one variable. So next I'll be replacing P with the value of 54, which was given to me. I know that my length is 2 times the width minus 3 plus 2W. So I replaced that P with the given 54, and remember they defined the length for us and told us that it was 3 less than twice the width, so I'm replacing that L with 2W minus 3. Once I have my equation written, I'm going to go ahead and distribute. So here I got my arrows popping for my distributive property, and now I'm going to bring down 54, which equals to 4W minus 6 plus 2W. From here, I'm going to be combining my like terms, so that 54 still comes down, and 4W plus 2W gives me 6W, and I'll bring down that negative 6. From there, I'll be adding 6 to both sides, like so, and you'll end up with 60, which equals to 6W. All right, so knowing that all I have to do now is take my 60, which equals to 6W, and divide both sides by 6, I know that the width is 10. Just like that, ladies and gentlemen. So my width is 10. All right, well, that's the answer to the problem. So here, ladies and gentlemen, if I were to go back here and make sure that you're answering the question that they had, they said that they wanted you to find the width. We were able to find that the width of this rectangle would have to be 10 centimeters, and that's the answer. So 10 centimeters is what the width equals to. And that's it. Done and done, ladies and gentlemen. That's the answer to the problem. Width equals to 10. So that's problem number one. Let's move on to the next word problem. Problem number 2. In our next word problem, it says that a triangle has a perimeter of 30 centimeters. Two sides of the triangle are each twice as long as the shortest side. find the length of the shortest side. So what I'll do first of all is, once again, draw a picture. All right, so let's see if I can draw a triangle today. All right, that's not bad, that's not bad. I've seen worse, And we do know that two of the sides of this triangle are going to be each twice as long as the shortest side. So let's say that this bottom side here is my short side, that's my unknown value, and that the other two sides are going to be twice as long as that. So that means that this will be 2x here, and that'll be 2x. So first of all, draw the shape and then label the shape with the information that you find in the word problem. From there, keep in mind that they said that we were dealing with the perimeter of this triangle. And anytime you're asked to find the perimeter of a triangle is simply the sum of all three sides. All right, so you just simply add the three sides together. So that being the case, I'm going to replace all these values here with my definitions and the given information. So then what I'll do is I'll be replacing that P with the given 30 centimeters that they told me about. And I'll be replacing A, B, and C with my labeled sides that I have right here. I'll be starting with my short side x, so that's going to be x plus 2x plus 2x. All right, so there's my equation. Next, we're going to combine like terms and solve for x. On the right side of the equal sign, we have 1x plus 2x plus 2x. That gives me 5x. Then I'm going to divide both sides by 5. So my 5's cancel out, so I bring down my variable x, and 30 divided by 5 is 6. So, ladies and gentlemen, that means that my short side is equal to 6 centimeters here. All right. And let's make sure that we're answering the question here. It says to find the length of the shortest side. Well, my short side is 6, so that's going to be my answer. That's it. Let's go ahead and put a red box around that, ladies and gentlemen. 6 centimeters is the result. Okay? And that's it. Problem number 2. Done and done. All right, let's keep it moving. Coming your way is problem number 3. Here our word problem says the second angle of a triangle is 20 degrees less than the first angle. The third angle is twice the first angle. How large are the angles? So here, ladies and gentlemen, we once again are dealing with a triangle. So I have a triangle set up just like so, all right? And I'll be going around my triangle here, plugging in information. So with this known, I'll say that I have angle 1, angle 2, and angle 3. I'm going to make a little list of my 3 angles so that I can define them. I have angle 1, angle 2, and angle 3. Okay, out of our word problem, we want to determine which angle we don't have any information about. We're told that the second angle of a triangle is 20 degrees less than the first angle. We're also told that the third angle is twice the first angle. So we really don't know what the first angle's measurement is. We don't have any information about it. So that's going to be my unknown value, that angle 1. From there, I'm going to go ahead and state that the second angle of the triangle is 20 degrees less than the first angle. So that means that it's going to be x minus 20 as far as my definition for angle 2. The third angle was twice the first angle. So that's going to be 2x. So we have all 3 angles defined. One thing you should know about a triangle is that the sum of the interior angles of a triangle, all 3 angles, angle 1, angle 2, and angle 3, they must equal to 180 degrees. So let's write that out. We'll say that the measurement of angle 1 plus the measurement of angle 2 plus the measurement of angle 3, that has to equal to 180 degrees. From here, we'll be replacing our values that we have for the angles here with our definitions. So we said that angle 1 would be x plus angle 2, which is x minus 20, plus angle 3, which is 2x, and that has to equal to 180 degrees. All right, so we're going to be combining our like terms and solving for the variable x now. So I have 1x plus 1x, which is 2x, and 2x plus 2x is 4x, minus 20, which has to equal to 180 degrees. From there, I'm going to be adding 20 to both sides of my equal sign now, and that gives me 4x, which now equals to 200, and then dividing both sides by 4, we find out that x equals to 50. All right, so now that we know that x equals to 50, let's go back to our definitions for our angles here. We find out that angle 1 is 50, so if x is 50 degrees, ladies and gentlemen, that means that our second angle, which is 50 minus 20, has to be 30 degrees, And then our third angle, which is 2 times that first angle's measurement, will have to be 100 degrees. And that's going to be all 3 angles, and they all add up to 180 degrees. So these angles are the answers, ladies and gentlemen, just like that. 50 degrees, 30 degrees, and 100 degrees. Okay, let's keep it moving. Keeping it moving, ladies and gentlemen. That's right. So here we have it. Problem number 4. The sides of triangle ABC have the ratio of 2 to 3 to 4. If the perimeter of the triangle is 54 inches, find the length of each side. Anytime you have a ratio when you're setting up sides of a triangle or a shape, that simply means that each of the sides have the same scale factor. So what we'll do first of all is go ahead and draw our triangle. Okay, and setting this up, we'll set it up with sides that have a ratio of 2 to 3 to 4. So I'll say that 2 times that scale factor is going to be that side, and I'll have this side as 3 times the same scale factor, and then I'll have this side set up as 4 times that scale factor. Alright, so when things are in a ratio, they're all multiplied by the same scale factor. So this is showing that it's going to be 2 to 3 to 4, and that's the relationship there. That's the ratio that they are expecting us to have. They then go on to say that the perimeter of this triangle is 54 inches. So if I have sides of 2x, 3x, and 4x, that x being that unknown scale factor, then I can set up my equation as such. I'll say that I have 2x plus 3x plus 4x, and that has to equal to 54. Just like that. From there, let's go ahead and combine like terms. So 2 plus 3 plus 4, that always gives me 9. So I'm going to end up with 9x equals to 54. From there, I divide both sides by 9, and I find out that x has to equal to 6. So 6 is that scale factor. So remember, my 3 sides of the triangle here were 2x, 3x, and 4x. So if I say the first side, second side, and third side were being represented by 2x, 3x, and 4x, so now all you have to do is plug in 6 for x to find out what these values are. So this is going to be 2 times 6, which is 12. I'll have 3 times 6, which is 18. I'll have 4 times 6, which is 24. And these are going to be the lengths of each side, ladies and gentlemen, just like that. 12, 18, and 24. And guess what? You add all those together, you'll end up with 54 for the perimeter. And that's the problem, ladies and gentlemen, just like that. That was problem number 4. All right, keeping it moving. Next problem. Here, ladies and gentlemen, in problem number 5, it says the measure of angle FBT, Fort Bend Tutoring, is 1/3 as large as the measure of its supplement. Find the measure of angle FBT. Well, we can set up supplementary angles in several ways, but the way I'm going to choose to do it is as a linear pair, just like this. So I'm going to draw my shape of 2 angles here. I'll be labeling this as FBT, just like that. And the word problem tells me that the measure of angle FBT is 1/3 as large as the measure of its supplement. And I know that FBT's supplement, this angle right here on the left side, is going to have a value that's not known to me. So that's going to be x. The value of FBT is going to be 1/3 of this value. So I can write this angle measurement as 1/3 x. And combined, as I told you before, these 2 angles have to equal to 180 degrees. All supplementary angles equal to 180 degrees. So I can set up my equation like so. I can say that x plus 1/3 x has to equal to 180 degrees. From here, I'm going to go ahead and choose to get rid of my fractions here. Don't want to deal with a fraction. So I'm going to multiply each and every term by 3. All right. So the same techniques I use in solving my linear equations, I use definitely when I'm working my word problems out. So I'll be bringing down my 3x. Over here, my 3's will cancel out to leave me 1x, which equals to 540. From there, I'll be adding the x's together, so 3x plus x, all right, and this is a plus sign right here, just in case you needed to know that. 3x plus x is going to equal to 4x, which equals to 540. Dividing both sides by 4, we end up with x equaling to 135 degrees. So that's the value of my supplement. Here, they want us to find the measure of angle FBT. So in order to find out the measure of angle FBT, knowing that this is 135 degrees, is that we can take a third of this value, or we can simply subtract this 135 from 180 degrees. So 180 degrees minus 135 degrees leaves us with 45 degrees, ladies and gentlemen. And this is our answer for angle FBT. All right, so let's go ahead and box that up. 45 degrees is the measurement of angle FBT. Fort Bend Tutoring. All right, so there you have problem number 5, ladies and gentlemen. Just like that. So keep in mind, supplementary angles, they add up to 180 degrees, and we drew it, we defined our angles, and we solved for it after writing our equation. There it is right there. You were with me. You were right there. You were right there. Okay, so next we have our last and final word problem for today's tutorial. So example 6 has the following. A sailor on a ship sights the light of a lighthouse at an angle of elevation of 15 degrees. If the light in the lighthouse is 189 feet higher than the sailor's line of sight, what is the horizontal distance between the ship and the lighthouse round to the nearest foot? Now, not only is this a geometric word problem, ladies and gentlemen, this taps into trigonometry as well. So we'll be using trigonometry in order to solve this problem. But first, we want to set it up with a drawing. So what we'll do is we'll say that our boat is at this point right here, okay? And we have a light at a lighthouse that's coming from a point, let's say right here. So what we can do, ladies and gentlemen, is we can say, all right, so the distance from the ship to the base of the lighthouse over here to where the light is, and knowing that this sailor is looking up at the light, is going to make what we call a right triangle, ladies and gentlemen. That's it. We have a right triangle. So once again, you have the ship here, we have the lighthouse light way up there, and you connect the dots there and you'll end up with a right triangle every time. So that being the case, we are going to fill in the rest of the information that was given. We were told that this angle of elevation is 15 degrees. We were also told that the height of the light from the lighthouse is 189 feet. Okay? Just like so. And then we also need to find the horizontal distance, this value right here, okay? The distance from the ship to the base of the lighthouse. That's what we're looking for. Using trigonometry, ladies and gentlemen, from our angle here, we have the opposite side over the adjacent side. Anytime we have the opposite over the adjacent side, that trigonometric function is tangent, or tan. So we can write an equation to represent this relationship here. We can say that tan of 15 degrees equals to our opposite length, which is 189, over our adjacent length, which is x. Just like that. All right. Now, in solving for x, we can do the following. You can set it up as a proportion and say that we have tan of 15 over 1, which is equivalent to 189 over x. And then you can cross multiply. And then by doing that, you'll have x tan of 15 equals to 189. And then go back and divide both sides by tan of 15 degrees. All right. So here we have the following result. Your result is going to be 189 divided by tan of 15 degrees, which is equivalent to 705 feet when you round it to the nearest foot, which is what they asked us to do in the word problem. Remember, round to the nearest foot. So you'll end up with 705 and 3,576 ten-thousandths, but when you round it to the nearest foot, ladies and gentlemen, you'll get 705 feet, which is the distance between the ship and the lighthouse. And that, ladies and gentlemen, is the answer to this word problem right here. All right, so remember, we were covering geometric word problems, and this particular one, we needed some trigonometry in order to figure it out. We do have a video on helping you find the 6 trigonometric function values, so I'll put a link right down here, so check that out, ladies and gentlemen. All right, so this wraps up this tutorial on geometric word problems, ladies and gentlemen. Remember, always draw your figures first. They'll help you out a lot. And this is Mr. Witt from Fort Bend Tutoring. As always, please rate, comment, and subscribe, and if you're able to donate, please do so. Peace.
We're going to be learning about such things as linear, quadratics, system of equations, tables, mixtures, work, oh Lord, distance, interest, of which I don't have much, investment. This is my favorite one. I'm going to name my grandbaby consecutive integers, algebraic translations, and percents. I understand a little bit about percents. I know that 50% off is pretty good.